Well, good morning. I'm Michael Kitchin. I'm with Wood Environmental Infrastructure. I'm going to talk a little bit about LIDAR and uses. We have approximately 100 offices around the U.S. and 11 to 14 offices that provide geomatic services across the U.S. Wood is an extremely large company. We have 600 offices around 60 countries. We provide conventional survey, remote sensing, and utility services. With our conventional surveying, we provide ALTA surveys, infrastructure for DOTs and local governments, GPS, hazmat surveys, industrial, hydrographic, GIS, and construction services. For remote sensing, we have a few different options. We have a mobile LIDAR system and 2 terrestrial scanners, as well as an unmanned aerial system we use for modeling as well as infrastructure. In our utility services, we have a few Hvac trucks across the U.S. We provide concrete scanning, ground penetration radar, and pipe camera extraction. On to LIDAR. What is LIDAR? LIDAR is a surveying method that provides measure distance to a target by providing illumination to the target with pulsed LIDAR light and measure the reflected pulses with a sensor. LIDAR is short for light detection and ranging. LIDAR is usually popular with a lot of high definition surveys. We do a lot of work with our local NCDOT here in North Carolina and Mississippi. LIDAR is also sometimes called LIDAR scanning, laser scanning, 3D scanning. We also use airborne, terrestrial, and mobile LIDAR applications. Mobile LIDAR is very popular with local and government DOTs here. So one of our scanners, the Leica P40, the LIDAR data and HD photos can be acquired in less than 15 minutes. Typical survey requirements and accuracy is approximately 1/100th of a foot vertical and horizontal at a range of 100 to 150 feet. The scanner has a range up to approximately 1,000 feet. The LIDAR density is not as great as it would be at a 100 to 150 feet. We can also provide ground control, which could be added for georeferencing. The Leica P40 is capable up to 1 million points per second. The data can be exported and extracted to MicroStation or Civil 3D, CloudWorks, and Jetstream. We also use AutoCAD's Recap and Leica TreeView to view the data. The LIDAR is usually used for high population areas and traffic areas where you can't get a full survey crew. We use LIDAR for areas that are high density areas where survey crews where it's more safe. Using LIDAR, like when we have survey crews, our data or our equipment is capable of working in hostile conditions. Sometimes our data or our survey crews aren't in the best locations. The LIDAR can penetrate some wet surfaces depending on the location and distance from the surface. When using LIDAR tunnel scans, the tunnel can be wet, as you see on the scanner. We use that scanner in I believe the snow as well. One of my favorite scanners to talk about is the Leica BOK 360. I call it the coffee can scanner. If you have a coffee mug on your desk, about a 32-ounce mug is about the size of this scanner. Weighs approximately 2.2 pounds and is 6.5 inches tall. It is capable of 360 points per second. It provides high definition and regular standard definition imagery. It can be provided in less than 3 minutes. This scanner also uses a tablet to be used, which we can provide data on site if needed. Typically, the accuracy is around 200ths of a foot at 30 feet and 35 feet, which with a range of 60 meters. This scanner is so small that we can also put it in ventilation systems. So why LIDAR? LIDAR is used for, we can have increased safety, the large data sets, it's used for high accuracy, reduced field time, faster than traditional methods, and no need for multiple trips. With the larger data sets, compared to a traditional field crew, there's no need for multiple trips. The LIDAR scanner can scan up to 1 million points per second. Terrestrial data scanning applications used for as-built, MEP inspection, volumetric surveys, clash detection, structures, and floor flatness. I want to run through some traditional scanning visualizations. This is an intensity hue colorized point cloud looking at a footing from a whirl tower. The whirl tower is used for spinning blades from a helicopter, and the whirl tower is used to measure imbalance and capabilities of a helicopter blade. This is a grayscale colorized point cloud of interior of a second floor plant. The LIDAR is so dense that it can be a plaque from 40 feet away can be read. This is the visualization of intensity of a colorized hue point cloud versus the realistic point clouds of Spirit Lake and Mount St. Helens. With the combination of the photos as well as the LIDAR, it can be used for a realization point cloud. It gives an RGB value to all points. Spirit Lake Dam is just forming another project. The intensity hue shows the reflectivity of the object with the photorealistic uses of the 360-degree pictures. This is a quick video of a manufacturing plant that we scanned. This required roughly about a 10-hour day with 65 scans. We provided this data in Recap as well as TrueView. TrueView is a free software that Leica provides to clients to be able to view their data if you do not need a model. Terrestrial scanning and as-built plants. On the left is the as-designed model. On the right is the as-installed. We scanned a transformer as well as the beams and bus bars above. As you can see from the two drawings, that the bus bar was installed center instead of 1 foot and 1/8 inch offset as designed. The bus bars and transformer and trying to find my place here. The center line existing isophase bus is offset other than as designed. Turns out it wasn't. The image of the left is proposed and the image of the right is what it actually looks like. The contractor ignored the plans and built the pipe shown in the middle of the pit and not offset to the left. This is a terrestrial scan as-built plan plots. We get a lot of requests for a 2D plan plot. This is a surge tank and air stripper for a manufacturing facility. They needed an update of their new surge tank with valves and the pipes. The terrestrial scanning as-built pipe modeling. This is overlaid on a grayscale. A lot of manufacturing plants request pipe modeling as they update their pipes throughout the plant. This is a terrestrial scan as-built BIM of the Orlando International Airport. This was used to verify the length and width of the new terminal that Orlando is building. They needed to verify the width and length for their terminals. As the tram moves in, there is a step bar that moves down onto the top of the terminal, and they need to verify the accuracy within 1/8 of an inch. The terminal will provide a hub for multiple modes of vehicle and rail transportation, including rail and commuter and light rail. Wood performed this as an as-built survey that included the location and traditional dimensional mapping of the existing rail, viaduct bridges, and evaluated platforms located in the intermodal terminal facility. The certain methods for this horizontal and vertical control were established using the combination of global navigation satellite GNSS and digital differential surveying and leveling and robotic total stations. The existing condition features were captured remotely using terrestrial high definition laser scanning techniques that produced a 3D point cloud and model of the project, which specified precise featured positions were extracted and mapped to document the constructed improvements. Traditional for as-built MEP, on the left is the colorized or the gray colorized point cloud versus the interior photorealistic point cloud. Terrestrial scanning for HVAC planning. This is roughly a 20,000 square foot floor plan used for room occupation, room dimensions, and the reflected ceiling plan. When updating HVAC planning, reflected ceiling plan is requested for lights, vents, and sprinkler systems. Dimensions of all rooms and occupancy were required for this project. LIDAR scanning is also used for inspection. Coming back to the World Tower here. This is a colorized point cloud of the metal fabric World Tower. The net is approximately 30 feet in the air. We use this, or the client wanted to use this as an inspection tool and to verify the width and length of the net to make sure there was no issues when the blades explode if there's an issue. Clash detection. What is clash detection? Clash detection allows the client to test the design and against the existing environment to ensure it is both robust and practical. In this way, any identical clash can be eliminated cost effectively at the design stage. It is contrast to the discovery of the site, triggering costly and time delays and material expenses. It may be advised to scan the object multiple times along the construction process at the end of the particular phases. At the various construction site, related work teams complete their works to the structural completion, installation, and MEP and fit outs. This project was completed for the Florida Power and Light for their transformer. This is also an area for clash detection. We use Navisworks for our clash detection. This is the middle of construction. As you see, there's a pipe being formed and fitted to verify the length and width to the beam. I know that in some manufacturing facilities, trains as well as tractor and trailers run through the middle of the facilities. We have a tool to verify the width and length of the train and its occupants or what it's hauling through the middle of the facility. We can run a simulation with the train or tractor and trailer to run through the facility to make sure that whatever they're hauling is going to fit. Terrestrial LIDAR is also used in the construction phase. This is a bridge on I-40 in North Carolina. This was to verify the widths of the beams. They're going to remove the bridge altogether. They're having construction, or they're having issues with crumbling of the concrete below. This particular bridge was built in the 50s. This is the Spirit Lake Log Dam at Mount St. Helens. We scanned this they're going to import or construct a new vent and new catch basin for this dam. The equipment was flown onto the site to a helicopter. We scanned around the dam for a new dam anchors and catch basin to be replaced at the dam. One of the last days that we were there, the winds were so bad that we couldn't get a helicopter in, so that we had to hike out of this particular project. So we paid all this money for LIDAR, and you need to view it. How can I view it? So Autodesk Recap is one way. I know that with our company, we can view Recap, or we can request Recap through our Autodesk. It will run through each bubble view. It shows a photorealistic view of each LIDAR image. And everyone's favorite word, free. Like a true view is free to all clients. We get this requested quite a bit through each facility and each client. You can do the same thing through Recap. You can go to each individual scan and take view the photorealistic view to the point cloud. For each Recap and true view, you can go through and measure pipe diameters, bridge beams, facility beams, whatever needs to be measured. I also wanted to add in our drone services, and we have multiple UAS drones across the nation. We also have 14 UAS pilots. We also use a drone for inspection services for towers. It lessens the risk of issues with people having to climb towers. We do inspections for cell towers as well. We use scanning to support ventilation system design. Wood has conducted several ventilation system studies at facilities where pollutants exceed the permissible exposure limit. Many times these pollution limits are present because of poor ventilation system design or expansion of the system beyond its design capabilities. As shown in this photograph, these systems are routinely expanded, added on, or hoods are incorrectly eliminated without consideration of the effect of the overall ventilation system design. Most of the time, these systems do not have any as-built drawings to work with or begin making design improvements. Wood has proposed using this LIDAR technology to create as-built drawings of the existing systems to begin making design improvements in order to lower the concentration of pollutants in the indoor air. Wood has also proposed using the technology to support design and installation of new backhouse and new ventilation systems in order to confirm the space exists for proper installation. The terrestrial scanning during COVID-19. Remote sensing versus traditional survey crew, we have less crews, so we also have reduced field staff, reduced field time, exposure. We also get requests to do occupancy regulations to verify the occupancy of each building, and also real-time data. Going back to like a BOK 360, we also use it with a tablet where it can be exported in the field and given to the client to verify lengths and widths of their particular areas. Is there any questions? I also wanted to add my contact information in case someone has an upcoming project they may feel that LIDAR is useful for.